This is another question we have. This question is from limits. Okay, let's see. The value of the limit L is e to the power minus 1 by k, they are saying. Then the value of k, if L is equal to this quantity. So basically we have to find out the value of L, and we have to equate this value with e to the power minus 1 by k, and then we have to identify what the value of k is. So if this kind of situation happens, it's better to take the logarithm. Is not so difficult to identify. So let's take log both sides. So I can write here the ln of L. I could also write this whole entire thing as e to the power log. So let's do in that way also. No problem. So I can write this as L is equal to limit n approaches infinity, and this entire quantity I can write as e to the power log of this whole thing. There's an n to the power minus half 1 plus 1 by n. This is the one quantity we have inside the log, and then another quantity I have to write, which is 1 to the power 1, 2 square, 3 cube, n to the power n to the power 1 by n square, and this thing. Because when we are taking this as, let's say, x, so e to the power log x will become x. So now I have to deal with this thing, with the limit. If whatever I get, and if you take the log also, you get the same idea. So there's no such problem. So let's call this whole thing as p. Or let's say this is p, because if the log is useful, so we can use it. So I'm calling this entire thing as p. So basically this L will turn into limit n tends to infinity e to the power p. Or more precisely, you want to say that you can write e to the power limit n tends to infinity p, because n is involved there. So basically we have to find out what is the aim or what is the goal we have to achieve. The goal is we have to evaluate limit n tends to infinity, the p value. It means limit n tends to infinity, the log of this. Now you notice that after telling this much story, I have to do the real solution. So let me first write it. All right. So this we got, and now after taking log, what I get? This minus 1 by 2, 1 plus 1 by n will jump off from the log. First, this log will be separated into two different quantities. So log of n to the power this. So I can write directly what I'm doing. This is going to be the first term. This is second term. So we are this is kind of a log of x into y. So this I can write x, this is y. So we can write log of x plus log of y. So this is minus half 1 plus 1 by n, where it is 1 plus 1 by n log n. This is the first term I got. And the second term I get is what? 1 by n square log of 1 square into 2 square dot 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 till n to the power n. So these are the two terms we are getting. Now the problem is, how do we manipulate the whole thing? So now I'm calling this quantity as u, and we are going to evaluate what this is. So I have u, and that thing I have to find limit n approaches infinity 1 by n square. And notice that I can write this log by using the property of log as log 1 square plus log 2 squared, 1 square, not 1 to the power 1 rather, y square, then log 3 cubed up to log n to the power n. But you can also write this whole scenario as this way. Using summation sign, I can write r goes from 1 to n, the log of r to the power r, which can be further written as this thing, limit n approaches infinity, 1 by n square, and that I can write summation r goes from 1 to n, r times log r. Now this may give you the sense or the glimpse of definite integration as limit of sum. But the problem is this one. How? Because I need the function of r by n, and we don't see anywhere, because for limit of sum I need f of r by n and 1 by n here in the summation when r goes from 1 to infinity. But by trick we can manipulate. Let's try. So there is no problem with r by n here, 1 by n here, because 1 by n I can borrow from here. So I can write 1 by n, and this n I am giving to r goes from 1 by n, r by n, and this is log r. But notice one thing, this is okay. 1 by n I need, r by n I also got, but here r is actually a problematic thing. So what I'm going to do is I'm dividing by n here inside only and multiplying by n. So this way what will happen? This will happen into this situation. Limit n approaches infinity, 1 by n, summation r goes from 1 to n, r by n, and this I can write log of r by n plus log n with a big bracket. It means whatever we are going to do, I have to separate into two summations and two parts. How do we separate it? Limit n approaches infinity, 1 by n, and summation r goes from 1 to n, r by n, log r by n. This is the first summation we got. And the second one is again limit n approaches infinity, 1 by n, summation r goes from 1 to n, and this time r by n times log n. I hope it will work. So you notice one first thing. This first thing is indicating there's a 1 by n, r by n, r by n, and limit 1 to n. So this is definitely a definite integration as a limit of sum. So this I can write 0 to 1, because the limits are, the bounds are 1 to n, and 1 by n transform to dx, and r by n transform to x. So this will become x log x. It's a clear-cut integration I have, but here also some very interesting is going to happen. You notice the bounds are only on r, so this n and log n are constant terms, so we can take them out. So limit n approaches infinity, 1 by n, we are taking this n out, so it will become 1 by n squared, and log n also, and we are left with summation r goes from 1 to n, r. And you have done this kind of summation many times. Let's first evaluate this thing. So we'll give you x square by 2 into log x minus 1 by x into x square by 2 dx, and this whole thing 0 to 1. And here, by the way, what you are getting, limit n approaches infinity, 1 by n square, and this is log n into n plus 1 by 2. This n and this n will get cancelled. So here what we get is actually this is going to be x square by 2 log x minus 1 by 2, and again x square by 2. Yes, so 0 to 1, and this is going to be with the limit. I'm not evaluating the limit so far, so this is going to be n plus 1 by n, half of it into log n, and now the substitute there. So at 1 that will be 0, and at 1 again this will become minus 1 by 4, and at 0 it will be 0. So minus 1 by 4 plus this quantity. Limit n approaches infinity of n plus 1 by n log n. Now notice one thing. This is the same quantity what we have present in our expression here. Let me cut this expression and show what is going to happen. So this is the expression I wanted to cut from here. Let's copy it and it will go there. So this is going to be, I have this quantity. This is the expression I have to evaluate. So this u you got as the sum of these two. So I have this quantity here in present in u. So this will cancel this one with the limit as well. So we are getting the p value, the limit of p value and approaches p infinity, where p is minus 1 by 4. And the L value is e the power p value only. You can see there. We have written there. L value is limit e the power p. So limit of p already found. So this is going to be the power p. So that is going to be e the power minus 1 by 4. When we compare with e the power minus 1 by k, we get k is equal to 4 as the answer. All right. Let's move to the next question. Now in this question, the question demands to find out how many different ways this grids can be filled so that the given elements or the given numbers 2, 3, 4, 5, 6, 7, 8 are to be placed in such a way that each row or column sum will come out to be 21. And of course you notice that there is 2, 3, 4, 5, 6, 7, 8. There are 7 numbers and there are 7 squares also. And they're saying that 1 per square we have to fill. And of course we cannot repeat because 1 per square meaning the same thing. So how do we do that? Let's see. So suppose I'm telling that I have this A, B, C and D. And let's say this is E, F and G. So in that way we have occupied all the digits what we are provided. And we need this thing. The A plus B plus C plus D is 21. And A plus B plus C, not A plus B plus C, E plus C plus F plus G is again 21. If I get these all things, then of course our work will be fine. My point is, so what we can do here is first we identify what the C could be, because C is coming in the horizontal and the column both. So if you just add them together, I can write there A plus B plus C plus D plus E plus F plus G and plus C again is 42. And this is giving a very crucial information. You notice this all sum, this is the sum of all digits what we have. Sum of all digits what we have given, what we are given actually. So if you add them all, what we get? 2 plus 3, 5. Let me write it. 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So 7 digits, so 5 7s are 35 because they are symmetrical. So that sum is 35. So for C is equal to 42 minus 35. Therefore C must be 7. So when the central number is identified, that is 7, and this I can fill with 7. So C is equal to 7. Let me write like this. So C is going to be 7. This is fixed. Without 7, the sum is not achieved as 21. So now we have to identify that what is A plus B plus D. So already 7. So A plus B plus D is going to be 14. And again E plus F plus G is going to be 14. So you have to identify how we can make these two different sets, because we can't repeat the numbers in any of them. So first set represents ABD and the second set represents EFG, but the sum should be 14 for each. And we can also make it vice versa, or we can also swap it. So we can think that if I take 8, 2, and let's say this is ABC. Why I'm calling it? Because I can give them to anyone now. Let's say 8, 2, and 4. I think 17 is there. Sorry, 14 is there. Yes. And the remaining what we left out of 7, that is going to be 3, 3, 5, and 6. There is also 14. Yes. So I have these only two sets we can make. So either you can give 8 to 4 to ABT, or you can give to EFG. So for each row and column, I have two ways actually. In each case, I have 3 factorial and again 3 factorial. So I believe there is 36 to just 72, and that's the answer. All right. So this is another problem we have in which the vectors are given. So the question says that the AB, AC, AD are adjacent edges of a parallelepiped. The vector along the diagonal AP is given by vector A, so that magnitude of AP is 3. The vector areas of the faces containing ABC and ABD are respectively given by AB and AB cross AC, and that vector area is given by vector B, and AB cross AD is vector C. The projections of edges AB and AC on the diagonal AP are both equal to 1. Then which of the following can be correct? So one thing you notice carefully, that whatever options we have, these all options are in terms of small a, small b, and small c. It means you notice the AC I have to find, but in terms of small a vector and the b vector and the c vector. And also be careful in understanding that the vector b and vector c are the area vectors of the faces. They're not the components, or they're not the vectors along the edges. So what we do, I have already drawn the picture, and this picture is not going to help us that much, but still we have to visualize something. So you notice that the AP vector is the one of the diagonal vector. So the diagonal is the diagonal of the entire parallelepiped, not the diagonal of the face. So we have to take this diagonal here. So we take the diagonal, let's say this point is A here first. This is B. This is, let's say, C, and this is D. So in this way we defined AB vector here, AC vector, and AD vector. Now let's call them a name, because I don't want to write every time the AB vector, AC vector, and AD vector. So I'm assuming that the AB vector as the U vector, because I cannot assume A vector because A and B are representing something else. Then AC vector, let's say B, not B, the V vector, and the AD vector is W vector. And this is the vector which is the diagonal vector. So I'm joining this A to this corner. So this will give you, let's say this point is P. So I have AP vector. And since AP vector is already given, this I have assumed, but this AP vector is already given as A vector. Now let's go to the other information. The vector areas of the faces containing ABC. So ABC, this is AB cross AC. So I can say that the AB cross AC is now U cross V. So I can write B vector is U cross V vector. And the C vector is V cross W vector. So this way we have avoided writing AB, AC, and AD always. Now the projections of the edges AB and AC on the diagonal AP. So projection of AB, that is the U dot A divided by A, is equal to 1. But notice the magnitude of A is already given us, not implies, means it's the information rather. So I have the magnitude of the vector A is 3. Yes. So I'm going to use it. So this will give you U dot A is equal to 3. Similarly, the V dot A divided by magnitude of A is again 1. Therefore, V dot A is again 3. So these are the information. Let's just call it 1 and 2 so that we can identify where it is to use it. Now, after this, what they're asking is the AB, AC, not AB, yeah, AC, AB, CD, and AD in terms of these vectors. Now, how do we use these all area vectors and the A vector, diagonal vector, to write the side in terms of those? So for that, let's recall the vector triple product. Because in vector triple product, we can get this thing, U dot A and U dot V dot A somehow. But before that, you also identify one thing, that the vector A, which is the diagonal vector, can be written in the form of these sides, the AB, the AD, and the AC. How? Because you notice that the AB vector plus AC AD vector is going to be this vector here, the diagonal of this face, what you see in the bottom. And again, you take this A, whatever you call, let's say this point is M. So suppose you are getting the AB vector plus AD vector is AM vector, and you now take the AM vector plus AC vector, it will give you the AP vector. It means I can write the AP vector as the resultant of all these AB vector, AC vector, and AD vector. So can I write the A vector is nothing but the U vector plus V vector plus W vector. Now we can apply this thing that the magnitude of A is 3 unit. So let's try to think what will happen. So magnitude of A is 3. So magnitude of this I can write, or let's say square. So magnitude of A square, I can write the mod of U square mod of V square plus mod of W square, and this is going to be twice of U dot V plus V dot W plus U dot W. Now what we get, this mod of A is already I have, which is 9, but I don't think it will help, and we already have U dot A and V dot A, so why not we can directly multiply with A dot so that we can get W dot W dot A. Yeah, that's a wise step. So I avoided doing this thing, or let's keep it. If it is required, we will use it. So that is not working, so let's call it X, and here I'm going to multiply with A, so this will give you A dot A, and that'll give you U dot A plus V dot A plus W dot A. You notice the A dot A is already have that the mod A square, that is 9. So 9 is equal to, and U dot A is we have, V dot A we have the 3 and 3, that is 6. So 9 is equal to 6 plus U dot W, A dot W rather, or W dot A. In this way we got the A dot W or the W dot A is also 3. And here we already found that these values are also 3 respectively. So we have these 3 informations for U dot A, V dot A, and A dot W. Now, as I told you that we could recall the vector table product, and then we can do, let's see how we can do. Because I guess that this is AC vector, CD vector, we can find it by using this vector triple product. So what is vector triple product for the three vectors? You know that. Okay, I have a B vector here. So let's say I'm just taking A cross B vector. Why? Because I need this U dot A. Okay, so let's see. Let me just do first. So we can write A cross U cross B, U cross V rather. Because I have B vector as U cross B, so I'm finding A cross B. Notice that the B vector is the area vector by those faces. I mean the edges of that face. So what is this? This I can write A dot V vector U minus A dot A dot U vector V. A dot U vector V. You already know that was my guess, because I have this U dot A and V dot A. I could use this cross product A cross U cross V, and then we get A dot V and A dot U. But I realized that U cross B is nothing but B, so again I wrote it. So here A dot V is already we have, that is 3, and this is also 3, so I can write 3U minus 3V. This is another information we have. Can we do one more time with C? Yes, we can. So let's do A cross C. So A cross C is again A cross, this time V cross W. And since why we are doing so, now you see this is the useful information, A dot W. And here actually A dot W I identified eventually. I was not aware of whether it is useful or not. But when I found A cross B, it came to my mind that, okay, A cross C if I find, and the same way A dot W will be useful. So again, we apply here A dot W V vector minus A dot V W vector. And that is going to be, I have 3V minus 3W. This is the fifth one. So now you can realize that I have these three information. A cross B is equal to 3U minus 3B vector. A cross C is equal to 3V minus 3W vector. And also one information I can say that the U plus V plus W is equal to nothing but A. This is the sixth equation. Now you notice, now we cracked it. Wow, because this is actually 4, 5th and 6th. You just try to understand very carefully that A cross B is 3U minus 3B. So what is U? U is nothing but our A B vector. AD is, I have W vector, and AC is, I have V vector. And since I need any of this, because I need AC means I need V vector, I need AB means I need U vector. So can we not solve these three equations and find out the value of U? So let's find the V vector from 4. So from 4, what I can write the V vector? The V vector, let's say I can write 3V vector is equal to 3U vector minus A cross B. And from 5, I can write again 3W vector. I think here I have done mistake. V cross W perhaps, or wait. This is AB cross AD. AB is U na. Okay. Okay, so there is one mistake I have done. Here it should be U cross W, not the V cross W. So this was a very little mistake here, u, and this is a dot u, a dot w u vector, and a dot u w vector. Understood what the mistake I did here? So what I can get, because I was thinking that there how the v will come again, it will be difficult to eliminate. So here we get again, because this is going to be now u vector, and we can write the 3w from there, that is 3u vector minus a cross c this time. And we know that this is going to be v and w, so I need 3v and 3w, so I can just do like this. I'm substituting the v vector here, so u is equal u plus u vector minus 1/3 of a cross b. This is the place value I have taken. If you remember, if you understand, this is the value for the v. Now I'm taking the value of the w, I'm putting here. So w value is here. That is, again I can write u vector and minus 1/3 of a cross c vector, and that is equal to our a vector. So I have to find out the value of u. So I can see that there are 3 u's there. So 3u vector is equal to a vector plus 1/3 of a cross b plus 1/3 of a cross c. So I'm getting u vector as 1/3 of a vector plus 1/3 of a cross b plus 1/3 of a cross c. Which is further written as 1/3 a, and from there I can take this 1/3 common. We can write a cross b plus c. But you see, this is the value we got u, that is the value of ab vector, and the ab vector option doesn't matches, so c option is not correct. Now we can try to find out the ac vector, and the ac vector is nothing but v vector. So similarly, what we do, we will eliminate the u from this. We find the value of u and w from these two and substitute in this. So let's try. So from there you can notice that what is the value of u here. So u value is, I'm getting 1/3, means v vector plus 1/3 of a cross b. And what is the value of w I'm getting? So w vector we have already found here in terms of a cross c. So I'm going to substitute this u vector and w vector in the equation number 6. So this didn't work. So let me just, didn't work means it was not given in the option. So we will take it a little bit aside and we work for the other thing. So I have to find out the v vector. So I'm going to substitute the u as v plus 1/3. Sorry, I have to find the v rather. So I'm going the same thing, 1/3 a cross b, and v is already v, and w is again I can write from here. So w is u vector, w is u vector minus 1/3 of a cross c, and that is equal to a. But again you see there is a u vector here, so I can write this v vector plus v vector 2b vector plus 1/3 of a cross b minus c so far, and plus u vector is equal to a vector. I need to find the u vector. Again you can write the u vector from here. So you have 2v vector 1/3 of A cross B minus C plus U vector is again V vector plus 1/3 of A cross B is equal to A vector. Now this will become 3V vector, and again you can combine this thing. So 1/3 and again A cross B, so A cross and B will get added, so 2B minus C vector is equal to A vector. So V vector we got as 1/3 of A vector minus 1/9 of A cross 2B minus C vector. So in this way our first option is correct exactly. So this we got the first option. Now in order to find the other options work like CD vector, so for CD vector how do we find? You can notice the CD is nothing but what? CD we are adding here. So we have the AD vector, we have the AC vector. So first we find the AD vector, and AD vector is from there we can find, because you already found the U vector. Notice we already found the U vector here, we already found the V vector here, and we know that the U plus V plus W is equal to A vector. So W vector is nothing but the A minus the U plus V, because W vector is our AD vector. And once we get AD vector, we can find the CD vector as well, because you know that the AD vector is this one and CD vector is this one. So you notice the AC vector plus CD vector is AD vector. So A is acting as the origin. So you can find the AD minus AC, and that is the W minus V, and then we can get the this CD, and also before that AD. So in this way we can try this and do this. The remaining part I hope you can do it. Alright, so see you in the next video with some other GTA problem. Till then, stay math active.